Okay, this is a lesson on properties of exponents and using them to simplify algebraic expressions. So the first property we're going to look at is the product of powers with equal bases property. And just as a very quick review, get my pen right here. If I say 2 to the 5th power, remember this whole thing is called a power. And the 2 is the base, and the 5 is the exponent. So if I say product of powers, that means this is a power, a to the m, and a to the n is also a power, but notice they have equal bases. Both of their bases are a, so this is the product that tells us how to handle that. When I multiply such powers, what I do is add the exponents, and that makes sense when you look at an example without variables. So if I'm saying 5 to the 3rd times 5, or 5 cubed times 5 squared, what that means is 5 times 5 times 5, that's what 5 cubed is, and then times 5 times 5. So you'll see that what I have here are 5 5s being multiplied. So when I run into this situation, what I'm going to do is just add I don't need to expand it out like that. I can just go ahead and say this equals 5 to the 3 plus 2, or 5 to the 5th. Now, let's look at one with variables. 5x to the 6th times x to the 13th. What I'm going to do there is just simply add the exponents, and I'm going to say that's x to the 6th plus 13, or x to the 19th. All right. Get us the quotient of powers with equal bases. Notice that I have this power and this power. They're being divided. They have the same base. In this case, what I'm going to do is subtract the exponents, and let me show you why that is. If I have 5 to the 7th power, that means 5 times itself 7 times. And divided by 5 to the 4th, that's 5 times itself 4 times. And what the subtraction is, it's really accounting for the number of times the number of pairs of 5s you could cancel here. I was able to cancel 4 pairs of 5s, leaving me with these 3 5s in the numerator, so 5 to the 3rd. So that means that 5 to the 7th divided by 5 to the 4th is 5 to the 7 minus 4th power, or 5 cubed. I know that to be 125. So this is called the power of a product property. So you have this product x times y, and you're taking that to a power. And so just to understand that property a little bit, you'll notice that I have x times y cubed means x times y times x times y times x times y. And the commutative property and the associative properties allow us to put together what goes together. So this is really equal to x times x times x times y times y times y. And if I group the x's and I group the y's, I get that this equals x cubed times y cubed. So this is actually another form of the distributive property. So what this property tells me is that when I have a product to a power, I distribute the exponentiation over the multiplication here. So I give the 3 to the x and the 3 to the y, and you can see why using that example. So looking at this other example, if I have 2 times b, all that to the 4th power, what that really means, you don't have to write this out, but that really means 2b times itself 3 times, and so that's 3 2's being multiplied here and 3 b's. So this is really 2 cubed b cubed. We'll go ahead and say what 2 cubed is. That's 8 times b cubed. So let's get some things circled here. And now I guess this is our fourth property, is called the power of a quotient property. They all say what they're doing there. You have the power of a quotient. The quotient is x divided by y. And if you think about what that would mean x over y times itself 3 times. And so what you're ending up with here is x cubed over y cubed. So this is yet another form of the distributive property where I'm distributing the 3 to the x and the y over division this time, as opposed to when we used to do distributing exponentiation over multiplication. We used to distribute multiplication over addition and subtraction. Now we're in the next layer of the distributive property. So if I have down here q divided by 3 squared, that means q over 3 times q over 3 times q over 3. So again, we don't really need to do that now that we know this property. Actually, it's just squared, so it's just 2 of them. So this is really just going to be q squared over 3 squared, and I'll call that q squared over 9. Next property is the power of a, now we're up to our fifth property already, power of a power property. This says when I have a power taken to a power, this time what I'm going to end up doing is multiplying the powers, and you'll see why, because x cubed squared means x cubed times x cubed, so we know that this equals x to the 6. I'd add the exponents, and how did I get that? So when you take a power to a power, you want to multiply the exponents. And so I get x to the 6 when I take x cubed and square it. So if I cube 5 squared, the property tells me I want to multiply the exponents and get 5 to the 6. If I did it the long way and just expanded it out, that would mean 5 squared times 5 squared times 5 squared. So you can see where this 5 to the 6 comes in, and that I add the exponents there. But I can shortcut that by just multiplying the exponents in this situation. Look at some examples. This first example, I'm going to have b to the 7 times b to the 9. So this is the product of powers of the equal basis. So I'm simply going to add the exponents here. And I'll get b to the 16th. Here I have 3g squared times 2g to the 4th. So what I want to do here is, okay, in this next example, sorry, I got interrupted. So let me just go ahead and say what this is. This means 3 times g squared times 2 times g to the 4th. So I'm going to use the commutative property to reorder these items. And then I'm going to group what goes together. I can group the 3 times 2 and group the g squared times g to the 4th, and I'll get that this equals 6. And I'm going to add the exponents here, since this is product of powers of equal bases, so that will be g to the 6th power. So 6 times g to the 6th power. All right, and example 3, this is where I'm going to apply the quotient of powers with equal bases. And so in that situation, I subtract the exponents. So this becomes z to the 12 minus 6, because I'm canceling out 6 pairs of z's in the numerator and denominator. And so that's z to the 6th power. Example 4, I have 9a to the 4th c to the c cubed divided by 27a times c squared. So one thing you want to remember with the numbers that aren't powers, I just want to do regular old division and canceling with those. And the a to the fourth over a, I like to separate things out a little bit here. And I can just do the division here. That's just going to be 1/3. No exponent properties need to be applied there. And I have a to the fourth over a. I'm going to use the quotient of powers with equal bases. And that's going to be a cubed, and c, same thing with c cubed over c squared. And that's going to be c to the 3 minus 2, or c. I can put this all back together if I want to and call this a cubed c over 3. Alrighty, and example 5, I just got a whole lot of y's here. One thing I'd want you to realize, these parentheses really don't have any meaning here. This is really just y to the fourth times y to the 6, and this is really just applying the quotient of powers with equal bases. So I have y to the 4 plus, this really is a 1 plus 6. So that's y to the 11th power. Now in example 6, I have an example of where I'm going to need to apply the power of a power property, and I'm going to need to multiply the powers in this instance. So I'm going to have y to the 5 times 3, or y to the 15th. Example 7, just a whole lot of r's. I've got, lots of properties going to be going on here, namely the, going to have the, I could put these together first and just call it, and that would be product of powers with equal bases, and then I could do power of a power. That's probably actually just simplify it by using just those two properties would work out. There's different ways you could do this. So I'm going to just simplify this to r to the 5th to the 4th power, and then this is going to be r to the 8th to the 2nd power, and the product of powers with the power of a power property would tell us to multiply these exponents. So that'd be r to the 5 times 4, or r to the 20th. R to the 8 times 2 is r to the 16th. Now I'm back to product of powers with equal bases, and then I'm going to add the exponents there, so that's r to the 36th power. In number 8, I've got all these, a number in these powers being multiplied together, all taken the 2nd power. So I can't put anything together inside of here, so I've got to distribute the 2 to each item. So the way that's going to work is I'm going to have -3 squared, then I'll have x squared, and then I'll have y to the 4th squared and z squared. So that's going to be 9 x to the 4th, y to the 8th, z squared. In example 9, I'm going to have I have a power of a quotient and power of a product going on here. So lots going on. So I'm going to make that 4 cubed times u to the 6th power, and then I'll have 5 cubed times r to the 12th power. And so I'm going to go ahead and multiply those out. That would be 64 u to the 6 over 125 r to the 12th power. Example 10, you've got a lot of a's here, so this, I think I'm going to just really just try to put together the a's I can in the numerator and denominator before doing anything else. I've got 12 over 4. And then what else I have in the numerator, I've got all these a's, a squared, a cubed, a to the 4. So I'm going to add all those exponents and get a to the 9th. And then the denominator, I'm going to take the power to a power, so that's going to be a to the 8th. I'm going to be able to just make that 3, and then this is all just going to be an a, because 8 a's will cancel out of the numerator and denominator. I've got -2 times, similar kind of problem here. I've got a negative involved this time. So I'm going to have -2 to the third power, and then I've got these other r's. I've got r to the 6 cubed, and then I've got 3 cubed in the denominator, and then I've got r to the 5th cubed. So that's going to get me, the other way I could have done this problem, by the way, is I could have canceled r's. I've got r to the 6th and r to the 5th, and I could have just canceled that, and it's probably a little easier, but since I've already gone down this road, I'll keep going. So that's -8 over 27 times r to the 18th over r to the 15th. And so all that simplifies to -8. The extra r's are showing up in the numerator over 27. Number 12, I'm going to simplify inside the parentheses first. All those t's just boil down to, if I add the exponents, t to the 11th power, all that's squared. So I've got 4 squared times t to the 11 times 2. So that's 16 times t to the 22nd, or 16t to the 22nd. Just got one word problem here to show you. If I have an earthquake magnitude of 6.7 releases this much times more energy than an earthquake magnitude 4.7, and an earthquake of 4.7 releases that same amount times an earthquake of magnitude 2.7. How much more energy does an earthquake of magnitude 6.7 release than an earthquake of magnitude 2.7? So I'm just going to really just have 30 to the second times 30 to the second, and that's going to be 30 to the 4th power times the magnitude. All right, and that's the end of the lesson.